Hi, in this section, we're going to be putting it all together. So it's important to understand when we're going to use a mean or proportion because there are two different scenarios, right? And so the mean means that if it doesn't tell us it's normally distributed, we have to be able to determine whether the data or the original population is normal, and that's if they give us a sample that's at least 30. The mean of the random variable is the mean of the random variable, and then sigma sub x is the standard error, right? So because we're taking a lot of samples and a lot of their averages and taking averages of averages, we have to go ahead and divide by that square root of n. But with sample proportions, remember it was a little different because if it didn't tell us that the population was normal, we had to actually end up doing a product in which this product on the left side had to be greater than or equal to 10. And so recall that if this product was not greater than or equal to 10 but less than 10, we could still do the problem, but we wouldn't be using these techniques, right? We would be using a binomial distribution back from section 4.3. So you would just use that same formula. Okay, but then we hope that this product will be greater than or equal to 10. And then remember that we always had to verify that the sample size is no more than 5% of the population. Second thing is that the mean of the sampling distribution is the population proportion, and the standard deviation of the sample proportion distribution is the square root of this quotient. So there are a little bit of work to do, and then what this section will do is just kind of put it all together and determine what scenario goes with what. So for example, if the city of Raleigh has 98 registered voters, there are two candidates for a city council in an upcoming election, Brown and Felice. The day before the election, the telephone poll of 250 randomly selected voters were conducted, and 142 said they vote for Brown. 90 said they vote for Felice, and 18 were undecided. Give a sample statistic p hat for the proportion of voters who surveyed who said they'd vote for Brown. The sample statistic p hat suggests that we might expect about how many of the 9,800 registered voters to vote for Brown. So in this case, we could see that they're giving us the scenario. They're telling us that it's a proportion and that they want us to find p hat and then find an expectation. So the first thing they wanted us to know is give a point estimate. So a point estimate would be p hat, where p hat is x over n. So recall that the number of people that were surveyed were 250 randomly selected voters. The number of people that had the characteristic of they vote for Brown, right? So we're looking for people who would vote for Brown. And in the statistics given from the sample, they say 142 would have vote for Brown. Okay, so p hat is just equal to 142 over 250. So if I put this in the calculator, I get 0.568. Meaning 56.8% of the sample would vote for Brown. Okay, the second piece they want us to discuss is how many of the voters might we expect. P hat suggests how many voters would vote for Brown from the population of voters in Raleigh. So it's saying that P hat suggests that 0.568 is the proportion of which who would vote for Brown. And then if we extend that to the population of the capital N, right, 9,800 voters, then we could expect that 0.568 times 9,800 would give us the number of voters that would vote for Brown. So taking that times 9,800, we get 5,566.4. So if I have 0.4 of a person, most likely I have all of them. So I'm just going to go ahead and round up to 5,567. So I would expect about 5,567 voters to vote for Brown. So we use the point estimates for to be able to predict things about the population. So that wasn't too bad. Okay, so now let's just say we have a company who wants to cut costs and improve profits. And so, according to Purchasing Magazine, 54% of companies surveyed outsourced some part of their manufacturing process in the past 2 to 3 years. Suppose purchasing contacted 555 of these companies. So the first thing we need to decide is, do we have a mean or proportion? Right? Well, my thing is, do they give us a mean? Do they give us a standard deviation? Do they say the word mean? No. In fact, they give us what? They gave us a percent. And so right away, because they do not give us any mean or standard deviation, I know it's not a mean. And I know it's a proportion. And that red flag is simply because they give us a percent, and I don't see any word of the mean is, standard deviation is. My red flag states that it is a proportion because there's no word of mean or standard deviation anywhere. So if I read through this, does it say anywhere that this is a normally distributed population? No, right? So we're going to have to go ahead, and no matter what, we always have to do part 1 and part 2 before. And notice the example for problems are just, these two parts are below, right? There's some space here, and that's your little red flag, or like, ooh, maybe I'm supposed to do something more here. And if it's a proportion, we have to check these two conditions, part 1, and then part 2 is the distribution. Okay, so part 1 says, the 1I in part 1 asks about normal, right? NP times 1 minus P. Well, I can see that N is going to be equal to 555, right? And then P is equal to 0.54 from the 54%. So if I take 555 times 0.54 times 1 minus 0.54, let's hope it's greater than or equal to 10. So 555 times 0.54 times 1 minus 0.54, we get 137.9. Okay, that is definitely greater than or equal to 10. So we can go ahead and assume that the population is approximately normal. Okay, and the second part, 2i in part 1, asks if n equals 555 is less than or equal to 5% of, and notice we're talking about U.S. companies that were contacted by this magazine. So 55% of U.S. companies. So do you think 555 companies is less than or equal to 5% of all U.S. companies? Like every company, like think of a little mall, right? Like a mall itself has about 50 to 100 companies, right? Businesses. So think about 555 businesses. I would definitely say yes, right? Yeah, so we're just asking like, is the sample size less than or equal to 5% of all US companies? I don't write it as 0.05n. I don't think it's clear. I think I want you to think about it in terms of 5% of the population. And what is that population? US companies. So get used to writing it like this, like 5% of the population, because I think it'll be easier to think about in real life situations and be able to make that determination. This part 2 and part 1 should be somewhat intuitive. Okay, so both of these are satisfied, right? So now we can go to the distribution, which is part 2. So part 2 of the distribution means the first thing we need to talk about is the mean, right? Mu sub b hat. Because we already distinguished that the population is approximately normal, we do know that the population proportion is 0.54. So therefore, mu sub p hat is equal to 0.54. The second thing is the standard deviation with respect to the sampling distribution, and that's going to be the square root of p times 1 minus p over n under the square root. So if I do that, I would have 0.54 times 1 minus 0.54 all over 555. And you could simplify this a little, especially because if we put it in the calculator exactly, I know that this is 0.54 times 0.46 over 555. So I just do this little subtraction and kind of make that product in the numerator a little more simple. Okay, so I have my distribution, have my little preliminary. Let's go ahead and finally start the problem. So exciting, right? So what is the probability that 338 or more companies outsource some part of their manufacturing process in the past 2 or 3 years? Write your answer as a percentage rounded to 2 decimal places. So now I've done all this preliminary, so I can just go dig into the problem now. So the first thing I'll do is actually write here the mean, which is the proportion 0.54, which we got from here, part 2, 1i part 2. And then we'll mark the 3 standard deviations away, which I already did ahead of time. So it'll be 0.48, 0.50, 0.52, and then on the right side 0.56, 0.58, and then 0.60. And we really want to label these. And again, you can always label them by taking the standard deviation in the calculator, in case you forgot from the other video, like the 0.54 times 0.46 divided by 555, right? And then just add, like if I added 0.54, I get the 0.56 that I see here. And then if I added it one more time, if I added the standard deviation to the 0.56, I get 0.58, and that's how I get that. So it's from the other, I demonstrated that in the other video. And so I just go ahead and do it ahead of time instead of, because, just for the problem to be a little quicker. Okay, now let me write this out. So let's see. So the first thing I know is I need a proportion, right? Because I don't really have a proportion here. So need a p hat. So I do know that 338 or more. So if n is equal to 558, then I know I'm observing the characteristic of 338 companies outsourced their manufacturing process. So p hat in this case is 338 divided by 558. So if I put that in the calculator, 338 divided by 555, it gets like this little decimal here. And I do like it to be exact. So if it doesn't seem it's reducible, but just so you know, just to draw it on the curve, notice it's about 0.61. So let me go ahead and draw that here. 0.61, whoa, that's way over here. That's p hat. So that means I'm getting like, let's see, or more. So or more, what does that mean? To the left or to the right? What's more? Well, a bigger proportion, right? So over here. It is really small, so I can only see that this is going to be a small probability. Okay, so now that we got that done, now I can go ahead and put it in my calculator. Let's go ahead and find this probability. Again, we're using normal CDF as usual because we know that the population is approximately normal. And then let me go ahead and move that over. Okay. So we're going to be looking for the probability that the 300, so p hat is going to be at least more than 0.61. Okay. So the normal CDF, left, right. So my left is actually the 0.61, but I think that when I put it in the calculator, I'll leave it as 338,555 because that way I can get exact, because notice this decimal goes on forever. And the right is 1E99 because it's the right tail, and the mean would be 0.54. And then I would leave the standard deviation to be this 0.54, 0.46 over 555. So go to second vars, and we'll put normal CDF, which is 2. And I'll go ahead and put in the 338 divided by 555. Now I know we mentioned it was 0.61, so you can try to use it, and I'm sure you'll get the same result. I just like rounding at the end. I'm like a nervous Nelly, Okay, so 0.54 is the mean, and then square root of 0.54 times 0.46 divided by 555. And then paste. So we get 5.533 blah 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 e to the negative 4. Now remember what e means. E is scientific notation for 10 to the negative 4th, meaning that there are 3 zeros before this 5 and then the 5 starts. And then notice that I get a 5 on the right of it, so I'm going to round this to 0.0006. 0.0006. So this means that this would be or 0.00 sorry, 1 second. So this means it would be 0.06%, right? Rounded to 2 decimal places as a percentage. So it's a pretty small percentage, and we could just see that this would be unusual. Let's write a note. This is an unusual event. Just kind of for thinking purposes. So for 338 or more companies to outsource their manufacturing process, if that's unusual, then most likely US companies aren't really doing it, especially since we know that we have a approximately normal population. Okay, so this is the process. So you're going to identify first the scenario, and then do part 1 and part 2 for both, either mean or proportion, and then you can start doing the problems. Okay, so now let's continue with some more examples of this particular scenario. So now it asks, what is the probability that 285 or more companies outsource some part of their manufacturing in the past 2 or 3 years? And then we're going to round the same. So I'm still looking for that 285 or more. Now that we did this first part A, we can easily just go into this one, right? So once again, I'm going to go ahead and put 0.54, and then 0.52, 0.5, and then 0.48, 0.56, 0.58, and then 0.6. And then in this case, we need our point estimate, and in this case, p hat would be 285 now over 555. So if I put that in the calculator, I get a decimal about 0.51, right? C. But it does reduce, right? 19 over 37. But just to get an idea of where it's at on my curve, it's about 0.51. So let me go ahead and draw that. And where is that? 0.51. Here's 0.5. Here's 0.52. So right here would be 0.51. And I'm looking for or more. So or more, does that mean to the left or to the right? That's right, to the right. You guys are so smart. I don't even know why I ask. So you can see now, just looking at the drawing itself and shading, you can see that here's 50% on this right side. We are expecting this to be more than 50%, right? In fact, because it's between the first and second standard deviation, right, it's 95%. Is 2 standard deviations away, so we expect it to be between 68 and 95%. See, we can tell a lot just by our drawing. That's my point. It's not that you have to note everything I'm saying. It's just we just know a lot just from the drawing itself. So the second part would be to go ahead and write this up and find the probability. So the probability that p hat is at least 19 over 37, or 0.51, is equal to normal CDF, right? 19 over 37, comma, 1E99, because it's to the right, 0.54, and essentially it looks the same as up here, except with this new fraction. 0.54 times 0.46 over 555. So if I put that in the calculator, and in fact, I think I'm just going to go ahead and go up and just copy from there because it's the same thing. The only difference is I'm putting in a new fraction. So let me do that. I have 19 out of 37. Enter. And so here I get 0.8947. Okay. And rounded to 2 decimal places as a percentage would be 89.47%. So, and we predicted this because 0.51 was in between the first and second standard deviation away. We knew it was going to be between 68 and 95%, and sure enough, it is. So what is the probability that 48% or less of these companies outsourced some part of their manufacturing process in the past 2 or 3 years? And write your answer as a percentage rounded to 2 decimal places. Okay, so what is the probability that 48% or less? So notice that they gave us already the proportion. So let me write that down. The p hat for it is 48%, but really it's 0.48, right? So if I draw this again, 0.54 and then 0.52, no, just keep it going. You know, write it every time because the more you write it and the more consistency you have, it'll go in your long-term memory. Don't let your hand get tired. Keep it going and then you'll remember it better later. So notice 0.48 here is right here is actually exactly 3 standard deviations away. And we're looking for 48% or less. So that is actually area to the left or to the right, less. That would be to the left. And we could see that it's going to be really small and a tail. Now, some of you could already tell that you kind of already know what it is, but we can go ahead and put it in the calculator anyways. So if I'm looking for the probability that the p hat sample proportion of a sample of 555 is less than 0.48, that's going to be equal to the normal CDF, right? 0.48. Oh, no, that's not right. It's a tail to the left, so negative 1 E99, 0.48, and then the mean, 0.54, and then the standard deviation, right? 0.54 times 0.46 over 555. Square root, close it. Okay, so let's go ahead and put it in the calculator. And I'm going to hit second enter, and it gives me again the same exact normal CDF, except now I'm going to go ahead and just edit these 2 first pieces, right? It was negative E99. One E99, and delete that 7. And this one will be 0.48. And it looks right. I got rid of all the extra numbers. Okay, but notice the mean is there and standard deviation is there. I think we're ready. So 0.0023. 0.0023. So rounding this to a percentage, we get this to be 0.23%.